So hi everyone. As announced in your Smart UMS, this chapter will be handled in a flipped classroom where there is no usual lecture as you sit in lecture hall, but instead you will watch the video that I will provided for these chapters and learn by yourself. But then you are compulsory to attend the tutorial sessions too. So this chapter is entitled as a wave and sound wave. It will be divided into two parts, which is wave and also sound wave. So this is the outline of chapter. The first outline is about waves itself. So first and foremost, we will introduce ourselves with what is this wave actually, how did we define the wave itself, and the next one we will study a few characteristics of or properties of waves such as frequency, amplitude, wavelengths, speed wave, and other else. And after that we will study a little on speed of wave on string. This is the example of strings such as music instrument that involve strings and etc. We also will learn about the interference of wave, where there are two types of interference of wave. I believe you did heard this uh, previously, but then we will touch this part into deep this in these chapters. Then we will also learn about the reflections of the waves. Now, on sound wave, first and foremost, we will introduce ourselves on how to produce a sound wave actually, and a few characteristics of the sound wave, the speed of wave, it comes with energy and intensity of the sound wave. And we also learn about wave when it in area of sphericals and plane. And last but not least is the Doppler effect, which is this will be a very important topics in sound wave, and it is also very new to you in these chapters. So what is wave actually? And what is the characteristics or properties of wave? Or how did we call it? Or how did we decide that it is a wave? And what is the type of wave? So we will learn on this part. So what is actually is a wave? Wave is by the books it is disturbance. By the books it is defined as a disturbance or variation that travels through a medium from one location to another location. Now, for example, when you drop a pebble into a pool of water, the disturbance produces water wave, which move away from the point where the pebble entered the water. A leaf floating near the disturber moves up and down and back and forth about its original position, but doesn't undergo any net displacement attributed to the displacement. So this means that the water wave or the disturbance move from one place to another, but then the water isn't carried with it. So that is actually wave. And there are few types of wave, which one of it is a sound wave. Anything that produce sound, we call it as a sound wave. Anything that produce sound and we can hear it, it is a sound wave. And we also have a wave on string. The a very familiar wave on string is such in musical instrument such as guitar, your violin, and etc. We also have a seismic wave. This is quiet. We call it as a silent wave actually because it is a very silent types of wave such as earthquake and a family of it. And last but not least, we also have what we call as a electromagnetic wave, it is a combination between electric and magnetic, where it is the combination of it we come with electromagnetic wave. The example of EM wave is such as visible light, the light that you can see, a radio wave or radio frequency, a television signals, and also X-ray. So this is wave. Now there are two types of wave actually. All that wave that we classify just now was actually divided into two types. The first one is transverse wave. So transverse wave is a vibration that up and down, and it is perpendicular to the directions of wave propagations. So it can be a draw as this one. As you can see, the wave or the vibration is actually up and then down, up and then down, and it is very perpendicular to the directions of the wave propagation. So let's say this is the directions of the wave, but then the directions of the vibration itself is perpendicular with the directions of the wave. And the other type of wave is longitudinal wave. It is an oscillations of the particle which is parallel to the directions of wave propagations. So it can be drawn as this one. As you can see here, the wave or the motions of particle or the oscillations of particle is from this point to this point, which is it is also parallel to the directions of the wavelength itself. So for let's say the direction of the wavelength is towards this way, so the directions of the particle also towards the directions of the wavelength. So this is two types of the wavelength. Now this is a video on how the longitudinal move or uh, longitudinal and also transverse wave move. So we can see that the longitudinal wave, as you can see here, the directions of the particles is in similar directions of the wave. So this is the directions of the wave. Meanwhile, for transverse, the directions of the wave is toward this way, but then the directions of the particle or the directions of the oscillation is towards this way, which is perpendicular with directions of the wave. So that was transverse and longitudinal wave. So this is some of the property of the wave that you should know, and me and you should understand. I think you are quite familiar with some of these words. The first properties is amplitude. We symbolize it in a capital A. Amplitude is the size of maximum disturbance or minimum disturbance measured from zero positions. So in this graph right now, amplitude is positioned in here. So amplitude is from this axis, the zero position, to the maximum wave or to the minimum wave. So this is amplitude. This is also called as amplitude. But this amplitude usually called as a positive amplitude, and this one will always call or usually call as a negative amplitude. The second properties is wavelength. We symbolize it as lambda. The SI unit was usually meter, but then some books might use centimeter as the unit. So wavelength is a minimum distance in which a wave repeats itself. So wavelength in this graph was positioned between the first maximum point to the next maximum point, or the first minimum point to the next minimum point. So this is lambda. And the third one is period, symbolized as T, and the SI unit is S, which is 10 for second. It is defined as a time taken for a wave to travel a distance or a wavelength. It is similar actually with wavelength. So in this graph, the positions of T also between the first maximum to the next maximum or the first minimum to the next minimum. If the graph is if the x-axis in the graph is time, or in second, and when the graph is in distance, the x-axis is in distance, which is the SI unit is meter. So this distance between this point to this point is equal to lambda. Now, I believe you are also familiar with the relations between the period and also the frequency. So I can also return the time or the period here with equal to 1 over frequency. So for let's say I was asked to find the frequency with the known value of period, so I can find the frequency by using these relations. Now, the next properties of wave is wave speed. We symbolize a V, a small little letter of V. The SI units is milli per second. Sometimes some books you usually use centimeter per second. It's up to the book or up to the questions you counter on. So wave speed is a distance traveled by wave in 1 second. Now, the definition is similar with the wave that you already know, which is it is a divisions between displacement and also time taken. So in this wave also similar, but then since the displacement in this wave is equal to the lambda itself or the wavelength itself. So the displacement is equal to lambda divided by the time taken. The time taken in wave is equal to period. So the time taken is equal to t. Now, if I need to relate this wave speed with the frequency, I know that the relations between t and f is equal to this one. So by replacing this value into these equations, I will get another equation that relate between the velocity or the speed with the frequency, which equal to these equations. Now, what is actually frequency? Frequency is symbolized as a F. The SI unit of frequency is Hertz. It is the name of the person that found this. It is Hertz also can be simplified into Hz, which we will usually use. And frequency is defined as a number of complete wavelengths produced in 1 second. So for let's say you have 25 Hertz, the value of frequency is 25 Hertz. You will know that in 1 second, we, the complete wavelength produced is equal to 25. So that was the definitions of frequency. The next properties is wave number or symbolized as a k. This is the reciprocal of the wavelength. So we can find it by using this equation where k is equal to 2 pi divided by lambda. 2 pi is 10 for the one circle of the wavelength. The next properties is phase angle or phase difference. These two terms is similar, but in some books will be used phase angle. Other books might use phase difference. It is symbolized as this symbol. The shape is kind of beans, and the definition is difference in phase between two sinusoidally varying quantities. So how to find the phase angle in your wave? It is usually defined by this formula where the phase angle is equal to 2 pi with times with x divided by lambda. X is the distance, lambda is the wavelength. Now we continue with the speed of light on strings. As I said earlier, wave on strings usually exist in things such as musical instrument that have a string. When you pick it or string it, you will hear some sound produced. So that was wave on string. Now, for a vibrating string, there are two speeds that we need or there are two speeds that we always need to consider. The first one is speed of physical string, which vibrates up and down. This will transverse to the string in the y directions actually. And the next one is the wave speed itself, which is this wave speed is the rate at which the disturbance propagates along the length of the string in the x directions. And The wave of the speed can be calculated by using this formula where v is equal to square root of f divided by mu. So v is the speed itself, f is the tension in the string, because as we need to produce the wave on the string, we have to put some force on it. And then the mu is the linear density, which is, it is similar with the equations of the density that we know. It is the divisions between mass of the string per unit length. Now that was speed of the wave. Now we come to the interference of light. I think you are quite familiar with the words of interference, but then the words of interference that you are quite familiar is mostly involving light. So in this particular topics, which is wave, we will see on what happen when two traveling waves meet and pass through to each other. Now it is said that two traveling waves can meet and pass through each other without being destroyed or even altered. Now for this type of analysis, the superposition principle was applied. So what did the superposition principle said? It is said that when two or more traveling waves encounter each other while moving through a medium, the resultant wave is found by adding together the displacement of the individual wave point by point. So this is superposition principle set. Now, there are two types of interference of wave. One, we call it as a constructive interference. In Bahasa, we call it as interference membina. The other one, we call it as destructive interference. In Bahasa, we call it as interference memusnah. So what is the difference between these two interference? This constructive interference, when the superpositions of two identical, as you can see here, this is wave 1 and this is wave 2. Both of these waves have a very identical transverse wave. When these two meet up, where one more thing, this identical wave also impinge to each other. Now, when these two meet up to each other or combine to each other, we can produce another wave that have very high or very increasing amplitude, just like this one. So as you can see here, when there are two, as you can see here, when there are two maximum amplitude meet each other in pairs, you can produce a very high amplitude here. But then, differently with destructive interference, when there are two identical transverse waves, but then it is out in pairs, as you can see here, the first wave have a very high or very positive amplitude, but differently with the second wave, we have a very minimum amplitude. When these two waves meet each other, it will destroy each other. So each pass will destroy the other pass, each pass will destroy the other pass, and they will produce a superposed wave. So this is interference of light. Now that is for part 1, which is wave. I will continue this video with the sound wave.